The next lecture is Basic System Components Part 1. Now we start with transmitters and receivers. The same basic functions are performed by all the transmitters and receivers that have been performed by many internal components and are complex. Simple block diagrams are used to describe both of them. So this is the block diagram of receiver and this is the block diagram of transmitter. There are just 5 basic building blocks that are consistent in all transmitters and receivers. So we can explain them in detail. The first is antennas. It is the first device. The electrical signals that are flowing down a conductor are converted into the airborne waves or vice versa by the antenna. The airborne waves are said to radiate out from antenna when they leave an antenna. Antennas can be active or passive. There are 3 things on which the shape and size of any particular antenna depends. The frequency that can be handled by an antenna is the first thing on which the physical characteristics depend. The direction of the airborne signal is the second thing, and the power is the third thing that determines the size of an antenna. Antennas may be omnidirectional or directional. There must be an even division of all the antennas of the RF energy in all directions when using an omnidirectional antenna. But if the RF energy has to be radiated in any particular directions, then directional antennas are to be used. The amount of RF energy coming out of both of these antennas will be same, but in case of directional antennas, the energy is divided over the smaller areas. An antenna pattern is a tool used by the RF engineers to know the design of the antenna. In antenna pattern, the antenna is represented by a solid dot in the middle and the power radiating out from the antenna is represented by a line drawn around the antenna. The 1/2 drop in the power radiating out from the antenna than that of the power at the antenna itself is represented by a line. This figure shows the 2 representative antenna patterns. As you can see on the left side of this figure, there is a circular pattern drawn equidistant from the center, which is the antenna. This is a typical omnidirectional antenna pattern and shows RF energy radiated equally in all directions. On the right side of figure is one of many possible directional antenna patterns. Notice that all the RF energy is radiated to the right of the antenna, which is still in the center. This antenna pattern might be used for radiating RF energy down a narrow mountain pass between 2 tall mountains. Next is one-dimensional antennas. A hunk of wire is used to make one-dimensional antennas that is arranged in a straight line or any other shape. The monopole and the dipole are the 2 most basic one-dimensional antennas. A straight wire antenna is a monopole that is 1/4 in length of the wavelength of the RF signal that has been radiated by it. The 2 monopoles connected together in a straight line make a dipole. A dipole antenna has a length of 1/2 of wavelength. 2-dimensional antennas. A lot more variety is offered by 2-dimensional antennas, from patches and arrays to horns and dishes. A square hunk of metal is comprised in a patch antenna, whereas a bunch of patches are there in an array in an organized 2-dimensional pattern. Next is smart antennas. Mobile telephony uses smart antennas that have 3 sets of antennas. There is a division of the cell into 3 120-degree sectors. 120 of coverage has been provided by each set of antennas and therefore 120 of beam width is there. The problem in using single antenna for 120 of coverage is wastage of RF energy and interference. Hence, the 120 sector should be broken into number of smaller sectors, each of having its own antennas, and the users can be tracked by them as they move within the sector, which is known as spatial division multiple access or SDMA. Switched beam and adaptive arrays are 2 types of smart antennas. Many narrow beam antennas are used in switched beam. Each of them are pointed in a slightly different direction so that the entire 120 sector can be covered. A single array antenna can be used by adaptive array, in which the antenna beam can swing electronically from one position to the next. So this is all in this lecture. Thanks.